Ethernet LANs. In this video, I'm going to talk about again Ethernet LANs, now about the logical function or data link layer function of the Ethernet. You know that Ethernet is working in two layers of TCP/IP. The first is physical, and the second is the data link layer. Okay, we talked about the physical function of the Ethernet in previous videos. For example, we talked about the fiber optic and also copper cable, and also we have some another information of or some another functions related to the Ethernet in physical layer. This is not relevant to our course. For example, the currents, the voltage, and or coding or another things in the physical layer. But we know that Ethernet now is working in the physical layer, and it's sufficient for us to know about the Ethernet physical, because we can use this information. More than this information is beyond the scope of the CCNA. Now in this video I am going to talk about the data link layer function of the Ethernet. It's so important for us because we are a network engineer, or we will be network engineer, and we need to understand the functions of the data link layer. For example, for Ethernet protocol or the other protocols, you will learn about them in the future. But before starting talking about the Ethernet LANs in about the data link layer, let me to say that all of the functions, all of the configurations, all of the maintenance of the Ethernet LANs, means all LANs in the world now is related to this video, to this layer, data link layer, and also the framing that we can see in this layer. Don't forget, in all of the scenarios that we are learning, we will talk about them in this course and also in another course. We need to use the information that I'm going to give you in this video. Because of that, this is an important video about the Ethernet LANs, and this is the fundamental step for learning the Ethernet LANs or for LANs. Okay, maybe some of the information should be upgraded or updated in the future videos. It's okay, but now it's necessary to understanding everything correctly. Let me to review some of the topics you learned about them in previous videos. You know that in TCP/IP we have 5-layer application, transport, network, data link, and physical. And you know that when we need to advertise, to send data or message, first the application should create that message, then the transport should for example make some things on this data, and finally we will have the segment. The segment should be addressed with the network layer. As you can see, this is the segment. Now the segment is for example, we are giving the segment to the network layer. In network layer, for example, the protocol IP should change or should convert the segment to the packet. Now we are receiving packet in the protocol of the data link. Because we are talking about the LAN, the only protocol that is available in today's LANs, it is the Ethernet, and the Ethernet one of the protocols of the data link layer. But this is only protocol of the LAN. But in WAN we have many protocols. For example, in WAN we have a frame relay, VIP or ATM or Ethernet in the recent years, and also another technology, point-to-point HTLC. You will learn about some of them in this course and another in the other courses. But for now, let me to say that, as I mentioned before, Ethernet is the only and unique protocol that we are using it in the LANs, and the Ethernet function is in data link layer and also in physical. Now I'm going to talk about the data link layer function of the Ethernet protocol. As I mentioned before, you know that when we are receiving the packet, this is the packet, okay, the number 3 is packet. The data link layer protocol should add two new header and also trailer to this packet. The first is layer 2 header and the second is the layer 2 trailer. Let me to write here, this is the layer 2 trailer, okay, layer 2 trailer or Ethernet trailer. For example, I will talk about the usage of trailer, and also this is the layer 2 header. In this part of this video, we will talk about the function of the header, the contents of the header, and also the contents of the trailer. You know that because we are using Ethernet and in the LANs, this is the layer 2 trailer or Ethernet trailer, and this is the Ethernet header. Okay, now I'm going to talk about the detail or components or fields of the data link header means Ethernet header, and also Ethernet trailer. Look at this picture. The right picture can give us a more detailed picture of the Ethernet header and also Ethernet trailer. Let me to show you. This is the Ethernet header. As you can see, from here to here is the Ethernet, okay, header. As I mentioned before, this header should be added to the packet. Because of that, this is the packet. Okay, I will talk about the detail. And this is the Ethernet trailer. Okay, Ethernet, then trailer. In some documents, maybe you see Ethernet footer. Both of them are correct, but it's better to say that this is the Ethernet trailer. Now we know that actually we are adding Ethernet header and Ethernet trailer to the packet. The next question is that what is the content of the Ethernet header and what is the usage of that contents? And after that, what is the content of the Ethernet trailer and what is the usage of that contents? Let me to talk about this in this part. Okay, two of the part of the Ethernet header and Ethernet header are understandable for us. You know that in the previous video I talked about the source MAC address and destination MAC address or addressing. Okay, in each Ethernet frame, this is the Ethernet frame. Let me write here, this is the Ethernet frame. You know that the product of the layer 2 or data link layer is a frame. We can create frame from packet. How? When you are adding header and trailer to the packet, you will have one frame. This is a frame, this is a packet, this is a segment, this is a data or message. What is the function of the address? You know that we are using address to identifying the receiver and also sender of this frame. This, as you can see here, we have two parts for address. This is the destination address. Let me to say this is the destination MAC address, and after that we have the source MAC address. What is the MAC address? You learned about the MAC address in previous video. You know that we are using MAC addresses in the Ethernet networks for identifying the source and destination. The source MAC address identifies the sender of this frame, means the PC or other device that create this frame, and it should send this frame. And the destination MAC address identifies the intended recipients of this frame, because you know that in destination MAC address we can use unicast MAC address, multicast MAC address, or broadcast MAC address. When we are using the unicast MAC address as the source and a unicast MAC address as destination, as I mentioned before, this packet should be sent from one system to one system. When you are using unicast MAC address in the source and multicast MAC address in the destination MAC field, we need to and we want to send the frame from one system to multiple system. And finally, when you are using the unicast MAC address in this field, and 12F means the broadcast MAC address in the destination MAC, you want to send this frame to all of the systems in your network. Because of that, you know the content of these two parts, and this is obvious for you. Source MAC address, in most cases we are writing SRC. SRC is the abbreviation of the source. And also we have destination. Okay, let me to write here, we have destination MAC address. Okay, as you can see, the length of the source MAC address and destination MAC address, both of them are 6 bytes. Why? Because the MAC address has 48 bits length. Because of that, it's equal to 6 bytes. 6 bytes means 48 bits. Okay, because of that, we can say we can understand the two field of the Ethernet header. This is obvious. Now I'm going to talk about the preamble and also SFD. Both of them are related to each other. First, let me to talk about the preamble and the content of the preamble. Let me to write here, this is preamble. Okay, what is the function of preamble? I will talk about that. After that, we have the SFD. Okay, again I will talk about the SFD, but let me to say that SFD is the abbreviation of the start frame delimiter or startup frame delimiter. Let me to write here, start frame delimiter. what is the function of the SFD and preamble? Let me first starting with the preamble. Okay, what is the preamble? Preamble is using for synchronization. Okay, what is the synchronization? Let me talk about that. We are using the preamble for synchronizing. Look at here, you know that this is a frame. In each frame we have many 0 and bits. For example, this is a frame. Let me write here, this is a frame, okay, or any combination of the ones and 0. Okay, when one system sending this frame, okay, to the destination need to find a way, for assume that we are sending this traffic to the destination, and PC2 should receive this for example frame, and after that it should verify the destination MAC address with the MAC address of itself, if the destination MAC address equal or same with its MAC address, it should accept the packet or frame. Okay, and if the destination MAC address is not equal, is not same with its MAC address, it should drop the frame, you know it. Okay, but here we have many ones and 0. How PC2 can understand where is the start of the frame and where is the end of this frame? How the PC2 can understand, can find the first and the last bits of a frame? Okay, we don't have any solution without any for example any header or any feature. If you send only the packets, for example, with the destination, the frames with only with destination MAC address, the PC2 cannot understand where is the start of the frame. Okay, where is the first of the frame or the last of the frame? Because of that, it can't understand where is the destination MAC address, where is the source MAC address. It can see only many ones and 0. Okay, because of that, we need a mechanism. This mechanism names is preamble plus SFD. Let me to talk about first preamble. Preamble, as you can see here, has 7 bytes. 7 bytes mean 56 bits. Okay, and the numbers that we are using in preamble is 101010 finally to 10, 56 1010. Okay, and a start of the frame delimiter, okay, has this content 101010 again 1011. You know that SFD has one byte length and the preamble has 7 bytes length, means both of them with totally for example have 8 byte lengths, and this means the 64 bits length. Okay, as you can see, we have this fixed combination of the ones and 0 in the start of each frame. For example, when you are sending a frame from PC1 to PC2, you should add this combination first. 56 means 7 bytes, 56 bits, or means 7 bytes of 101010. Then 1 bit 10101010. Okay, only 1 bit. Now this is 1 bit. Okay, and then 11. When the PC2 sees this combination, it can understand this is the start of the frame. Assume that now we are sending this traffic to the PC2, and assume that until here we have destination MAC address. Now the PC1 should add this combination. Okay, look at here, 11, then 10101010, many 10, and then when PC2 is receiving this traffic, it can for example count the number of 10. It can find, yes, we have 5610. After that we have again 110, 210, 310, and then 11. Okay, this is the stop, and now we can say that this is the start of the frame. And after that we have in the length of